All right, so let's we'll finish up section 3.5, but first I just want to make sure everybody remembers slope-intercept form. Okay, y equals mx plus b. We did it yesterday, but what are the m and what does the b stand for? Liam?
M stands for the slope and B is the y-intercept.
Yes, m is the slope and b is the y-intercept. Okay, Mr. Roy just went over a couple different ways you can do that. Rise over run, or the y2 minus y1 over x2 minus x1. Okay, is that the only way to write the equation of a line? What do you think? Is that the only way that you can write the equation of a line?
I'm saying, are you thinking back to something we did right before we went on vacation, right before we went on Thanksgiving break?
Maybe I was thinking of Monday.
Okay.
Did our equations we did on Monday look like that? No, they looked like, if we go back to the last example, they look just like this. Oh, I know what you think. They look like this, right? That's the equation of a line too. It's not slope-intercept form, but it's a different way to write it. Okay? Today, we're going to try to write things like this. Okay? We're going to stick with this form. Okay? And that's the form that's used a lot, okay? Especially on like MCAS. Okay, so just kind of a little bit of a warm-up again. What's the slope here? Tell me the slope. Marissa? Slope. -6. How about my y-intercept? 1. Right? Exactly like the questions you did on the homework.
Hey guys, you don't have to write slope and y-intercept because you already have it on there. You just have to fill in the blanks on your notes. Remember, these go rather than these ones on your notes going down, they go across the middle of the page. A, B, and C go across the middle of the page, and you need to write them in.
Okay, what kind of line is this? This is something we did on Monday. This was a special case. Yep. That's the horizontal line. Very good. When you have a perfectly horizontal line, what kind of slope is that? It's 0, right? It's not going up, it's not going down. Perfectly flat. Slope of 0. What about the y-intercept? Yeah, it's 8. It's the number that's by itself. All right. How about this one? What's a little tricky? What do I have to do here that's an extra step?
Oh.
Well, what's the problem with this that it doesn't look like A and B? What's different about it? Yeah, Ashley? So what are you trying to do? Trying to get y by itself. Yep. So who can tell me what's my first step to get y by itself? Liam?
Subtract 2x from both sides.
Yes, always subtract the number with x first. So what that does is it leaves me with 4y on the left. Now, I could write -10 minus 2x, but can somebody tell me a different way to write it? I want like this. I want the x first. Jordy?
-10.
All right, I like the -10. I'm going to put that at the end. But what am I going to put in front of it? What's below the -10?
Oh, 2x?
Careful, not 2x, but
Oh, -2x.
a -2x. All right, so actually one more step. So am I ready to find the slope and y-intercept now? Is my slope -2, y-intercept -10? No. What did I do wrong? Because we said that the slope is always the number with x, right? Why isn't -2 my slope? How come, Kyle? We don't have y by itself yet. So can you tell me my last step to get rid of that 4? Yeah. Divide by 4 here, here, and there. Divide by 4, that's gone. So this is my slope. But can anyone reduce that for me? What's negative 2 over 4? Careful, not a half. Negative a half. And this is my y-intercept, but I can also reduce 10 divided by 4. What number goes into 10 and 4? 2. So divide by 2 and divide by 2. What do you get? 5 over 2. Okay, minus 5 over 2. Okay. Any questions on that? So now, what is my slope? Slope is negative 1 over 2. What kind of slope is that? If I asked you to describe it, that's a negative slope. And what about my y-intercept? What would that be as a decimal? Because if you were going to graph that, you'd probably want to change that to a decimal. What's negative 5 divided by 2? Well, what's 5 divided by 2? You had $5 and you gave it out to 2 people. 2.5, right? This is negative 2.5, okay? But they didn't ask us to graph it, so we don't have to change to a decimal. Okay. Any questions on finding the slope and y-intercept? Okay. Next thing we're going to look at is how do you graph an equation in y equals mx plus b form? Okay. What's the other way we learned on Monday how to graph an equation? Besides the special cases, what did we do for graphing on Monday? And we did it in the homework, the last question. Yep.
Replace the x and y as 0.
Yeah, and what is it called when you do that? You're finding the... What are those 2 points you're finding when you replace the x with 0 and then the y with 0? The what? Coordinates of the what? Intercepts. Okay, so that's one way to graph. Find the intercepts, draw a line. But what if you don't want to find the x-intercepts? What do you want to do it differently? Okay, this is how you can do it without finding the x-intercept. Okay, step 1. Okay, so on your notes where it says step 1, write that in. Make sure your equation is in y equals mx plus b form. If it's not, how do you do it? That's what we just did. The last problem we just did, we rearranged it. Okay. So first, make sure your equation is already in y equals mx plus b form. Okay, step 2. After you get the equation in y equals mx plus b form, graph your y-intercept. What letter in this equation tells you the y-intercept? Liam?
B.
B. So you're going to look at B, and that's going to help you graph your y-intercept. Okay, once you graph that, you're going to have something like this. You're going to have a single point on your graph. Now, can you draw a line, only one line, with a single point? No. Because if you have only one line, you could draw, or you have only one point, you could draw lots of different lines through one point. So what do we need? We need a second point. Does anybody know what's going to help us in this equation get a second point? We already used the B. We're going to use the M. Okay? We're going to use the slope. Okay, so step 3. You're going to start at the y-intercept. Okay, so we're going to graph the y-intercept. All right, so we'll have something like that. And now from that point, okay, we're going to use the slope to find another point on the line.
Wait, can I just add things to that?
Yeah, were you going to do positive, negative?
No.
No. Okay. Let me just mention quickly, when you find the slope, it's going to be rise over run. What if the rise is going up? What direction, or what, how do you know if something is up? Would that be a positive number or a negative number? Up is positive. What about if the rise was down? What direction would that be? Negative. Okay. What about the run, if it headed to the right? How would you know to go to the right when you look at your run? What's that, Vanessa?
Positive.
Yep. If you have a positive number, that means you go to the right. What if the run, how would you know to go to the left if it was negative? Okay, so depending on if your rise is positive or negative, you either go up or down. If your run is positive or negative, you go left or right. Just follow those 4 directions.
Guys, just a couple things. You have those 3 bullet points on your chart there. First thing to keep in mind, all right, if you have a slope, so any slope, yeah, in the first bullet. So if you have a number with x, that's a whole number. -2, 3, 5. We're always going to put that over 1 because that bottom number is our run. We need to know where to go. All right? So any slope that's a whole number, we're going to put over 1. If your slope was, let's say it was 2x, you need to know that when I use that slope, it's going to be 2 over 1. Right, so any slope that's a whole number is always over the number 1. You may have we're only going to treat the top, if it's negative, if I have a negative, say if it's like -3 over 2. Right, that's my slope, -3 over 2. I'm not going to go, what direction would I go based on this -3? Who can tell me, what direction would I go? Down how many, Kyle? I would go down 3. From there, where would I go, Kyle? Left or right? Right. This is where some people get confused. I'm only going to treat the top number as negative. Don't worry about the bottom. That's still going to be positive. We're still going to go down 3, right 2. We're not going to go down 3, left 2. Only this is negative. So this means down 3, right 2. Right? We're only gonna treat that top number as negative, not the bottom number. Some people get confused with that sometimes. Next thing, last thing, we got to make sure we simplify the slope. Right? We got to make sure we simplify the slope. So that's that last bullet, simplify slope. That's when we're going to get to those 3 little arrowheads. We're going to get to that when we talk about this. So we got to make sure that we simplify the slope. If the number on top is bigger, If the number on top is bigger, you wanna check and see if the number on the bottom goes into it evenly. So say if we ended up, let's say we got a slope of like 6 over 2x. Right, maybe in the last step where y is not by itself, I have to divide everything by 2, and I'm left with this. What would that simplify to? Does anybody know? If it's 6 over 2, does anyone know what that would simplify to? 3, right? Because 2, the smaller number, goes into 6, the bigger number, 3 times. So our slope would now be 3, right? And like we talked about earlier, that would be 3. It's a whole number, so we're going to make sure that we know it's over 1. If you have to write and finish off the fraction, write over 1 to remind yourself, that's fine. If you know that it's over 1, you can just graph it that way, that's fine too. All right, so that's one thing you got to remember when you're simplifying slope. Number on the top is bigger. All right, if the number on top is bigger, see if the number on the bottom goes in evenly. Now we can talk about number on top smaller. All right, so number on top is smaller. All right, we got to see, is there a number that will go into both evenly? All right, can I reduce it? Let's say, I get this. 2 over 4x is my slope. Maybe there was a 4 attached to the y, and I had to divide everything by 4 to get y by itself. I might have this type of situation. What number goes into both? 2. So I would divide both things by 2 to simplify it. It would leave my slope as 1 over 2. All right? Last thing. I'll give you guys a second to get caught up. Because these are a couple of things that show up sometimes and people forget. All right, so again, number on top is bigger. We want to see if the number on the bottom goes in evenly. It might not always work that way. If it doesn't go in evenly, guys, leave it. Same thing here. If this is like 2 over 3, there's no number that goes into both evenly. Leave it. So a fraction is okay for your slope, as long as it's a fraction as long as it's simplified. If it's not simplified, you've got to make sure you do that. Last thing. If the slope is x, right? So we graph our y-intercept. All right? But now we need our slope. If the slope is x, what does that mean the slope really is? 1. Slope is 1. Or, remember, it's 1 over 1. What does that slope tell me to do? Up 1. Up 1. And then, what direction? Be a little more specific, Vanessa. I'm going to go up 1, and then right or left? Up 1, right 1. So when the slope is x only, we need to know that there's a 1 there, and we got to go up 1 over 1. All right, so those are 3 situations that you might have for slope when you have to simplify. All right? Everybody good with this? Yeah. Speak now, forever hold your peace. Everybody's good?
Wait.
Thanks, Fred. Keep it on my toes, man. All right, so let's look at this one. First thing we got to look and see is if it's in slope-intercept form. Who said no? Kyle says no. I agree. There's something on the side, on the same side as y. Y needs to be by itself on that left-hand side. Marissa? Yeah, the 2x is in the wrong spot, right? The x always has to be after the equal sign. We always want the x after the equal sign, and then we're just going to slide this number over. We're going to slide this number, this 2, in this equation would be the what? Would be the y-intercept. That's fine. Liam, you're good. Right? Because we know there's nothing attached to it. Both letters are here. I got my y, and I got my x. So that's my regular number is just my y-intercept. So, like Marissa said, I'm gonna subtract 2. Subtract 2x, subtract 2x. I think of it when I do this part right here, I'm gonna bring down my y equals, right? That's good, that's what I want. Y equals is always first. There's no number with y, another good thing. That means I don't have to divide. It's only gonna be one step, I only have to move the x and I'll be done. All right? I think of this as, can I combine those like terms? Can I combine them? I can't. No. Someone raise their hand and explain to me why I can't combine those like terms. Antonio.
Because the 2 on the top isn't 2x.
Yeah.
So x gonna
There's no x here, and this just isn't a number because it has a variable attached. So I can't combine them. But I still have to write that out. The negative 2x can't just disappear. All right? Can't happen. So I have to write it out. I always want my x after the equal sign. When I'm doing slope-intercept form, I always want my number with x directly after the equal sign. Has to be that way. Because the formula is y equals mx plus b. First thing I want is my y. I have that. Next thing I want is my equal sign. I have that. Next thing I want is my number with x. Someone tell me by raising their hand. What's my number with x in this problem that I just moved? Marissa? Negative 2x. I just moved it so I could get it in the right, so I can get it in the correct form. Or sometimes what I do, guys, I take it, I put a circle around it, and I draw a line and put it after the equal sign. All I'm doing is I'm moving it so I can get it in the correct format, right, in the correct form. Last thing I should have there is going to be what? Who can tell me? What's the last thing I have to put in there?
Oh, +2.
Plus 2. Done. In terms of getting it in the correct form, I am done. All right? Now we're going to graph it. So to graph it, someone tell me by raising their hand, to graph it, what's the first thing I need to do? Josh? In the y-intercept in this problem would be what? 2. Where do I graph 2? On the y-axis. Where would that be, Josh? Up and down or across? The vertical line? Okay, then where? Up 2, right? I'm going to go right on the y-axis, and I'm going to go to 2. Good. Who can tell me what to do next? Somebody I haven't heard from yet today. Elise, you know what to do? I graph my y-intercept. Now what am I going to use? So I've kind of already used the y-intercept. I already graphed it. I don't have to worry about that anymore. What do I have to do now? Use the slope, right? Now, go back to the origin. Who says go back? If you say go back to the origin, raise your hand. If you say go from the y-intercept, raise your hand. A lot of people out there not sure. All right, we want to make sure when we do this, we want to go from the y-intercept. We don't want to go back to the origin. All right, go, yeah, like Mr. Hager, like we have in the notes. From the y-intercept, we'll use the slope. And then we're going to have to find, all we're going to do is graph one more point, and we're done, right, Mr. Hager? Only one more point, and that's it. We don't have to graph it, do 2 points, let's do one more and they're done. Okay? So let's go, oops, sorry, Mr. Hager. All right, so we got that. So, Vanessa.
Since the negative is going to go down
Yeah.
to and over 1.
Which direction? Left or right?
That way. Right.
That's the situation we were talking about. We were talking about slope, right? So I'm going to do a little dotted line here. I'm going to do a little dotted 1. That's my imaginary 1. Like we talked about. If it's a whole number, we need to know that it's over 1. That whole number is going to be over 1. So, like Vanessa just said, from the y-intercept, like it said in our notes, I'm going to go down 2, because that's what the slope tells me to do. 1, 2, and then right 1. Remember, this is actually has 2 things we talked about in that slope section. Because number 1, it's a whole number, so we have to put it over 1. Second thing is we talked about only treating the top as negative. I'm gonna go down to the right. I'm not gonna treat the bottom as negative, I'm not gonna go down and to the left, I'm gonna go down to the right every time. And then I'm just gonna draw a line, if you want to, use your ID, connect your lines. Make sure, like Mr. Hager's doing here, make sure your line goes like all the way through the graph. Sometimes what I see people do is, they just draw a little line like this and that's it. Make sure it goes all the way across your graph. Make sure it goes all the way across. All right, so we had two things happen. We had quite a bit happening there. We had to make sure we got it in slope-intercept form. We had to make sure when we got the slope, we had to put it over 1, so we knew how to graph the slope once we graphed the y-intercept. And we also had to know that because the slope was negative, I'm going to go down to the right. I'm only going to treat the top number as negative. I'm not going to treat both things as negative. I'm not going to go down to the left. I'm going to go down to the right. All right? Let's take a look at the next one. First thing, someone tell me, first thing I gotta ask myself is what? Someone tell me by raising their hand. First thing I gotta ask myself. Somebody I haven't heard from yet tonight. Thank you, Vanessa, but somebody I haven't heard from. Shannon.
If it's in, why?
So what do you think?
No.
No, it's not. What's in the wrong spot?
The 3x.
The 3x is in the wrong spot. Good, thank you. Does anybody else? Now, someone else tell me. What do I need to do to get the 3x where I want it? Someone tell me by raising their hand. Elise. Good job. Subtract 3x. Where else would I subtract 3x, Elise? Excellent. Good. From the negative 3, so minus 3x. Very good. Here's my equal sign right here. Someone tell me by raising their hand. On the left-hand side of the equal sign, the left-hand side, over here, what should be there?
Y.
Ashley?
Y.
The y. Excellent. On the right-hand side, what's the first thing that should be after the equal sign? What's the first thing that should be there? Ashley?
The x with the number.
So what do I put? Tell me exactly what to write.
It'll be -3.
Negative 3x, right? The number with x always goes after the equal sign. What's the last thing I need to do? The last thing. No?
Oh.
Marissa? The minus 3, right? Just write that down. I can't combine those like terms. I'm just writing out the fact. I'm showing the fact that I can't do that. Number 1, to keep my equation balanced. Number 2, to get it in the form I want, to get it in the slope-intercept. All right, let's graph. Hannah, what do I do first? Graph, we want to just say that again? I'm sorry. Hannah said graph the negative 3x. That negative 3x is going to be what in our equation? Someone tell me by raising their hand. Someone tell me by raising their hand. That negative 3x. 80. That's going to be your slope. What do I need to graph first?
The y-intercept.
The y-intercept. Can you tell me what it is?
-3.
Negative 3. Where do I go? Y-intercept or x-intercept? Y-intercept. Start from the middle. Where do I go?
Down.
Down how many?
3.
3. 1, 2, 3. Graph it smack dab right on the y-intercept. Now, that's taken care of. I don't need that anymore. It's done its job. What am I going to do now? What am I going to do now? What am I going to use now? Use the negative 3x. Why? It's our slope, right? We go from the y-intercept and we use our slope. All right? So, Dominic, what is that slope telling me to do from my y-intercept? Huh? I'm going to graph it. How do I graph it? Like, well, I'm looking for directions here. All right. I want to use, and Mr. Hager just added in the 1. Not sure. All right, Ashley?
You go down -3.
I'm gonna go down 3. 1, 2, 3, then where?
Okay, fine.
Which way? Right or left?
The right one.
Right 1. Down 3, right 1. Same situation that we had in the last one, right? We got a whole number, we gotta make sure we put it over 1, and we need to remember that we're only treating the top number as negative. We're never gonna go down and to the left. We'll go down to the right, but never down to the left. We're only gonna treat that top number as negative, and like we said before, it's a whole number, so we need to put it over 1. All right? So, make sure it's in y equals mx plus b. Sometimes you might have to move, like in the last two we've done, you had to move the x. All right? Graph your y-intercept. From the y-intercept, use your slope. All right? Mr. Hager, you want to take a look at this one?
Okay, this one, I changed the wording a little bit from what you guys probably have printed. What I wrote means the same thing as what you had printed, but I wrote it the way you're going to see this on the test. Okay, that's the only thing that I changed right there.
So guys, make sure you add that also f of x equals 3.
Okay, you guys have a different statement. I think it says something like the y-intercept is 3. Is that what it says on your sheet?
Yeah.
Okay, that's how it's going to be worded on the test. Okay, so what they're saying here is a linear function. Okay, so in other words, there's a formula for a line where the dependent variable increases by 3 for every 1 unit, the independent variable increases. Right? So when they say dependent, which variable is that?
That's the slope.
Well, x or y? Dependent.
X.
The y, right? The dependent variable is the y.
And Brad, when you do something like this on a test, guys, we'll remind you in the question that the dependent variable is what?
How about the independent variable? X. Okay, so in other words, what it's saying is the y value goes up by 3 every time the x value goes up by 1. Okay, the y value is going up 3 every time the x goes up 1. And then they're also giving us this other fact. What's that first thing that I just said? The y value goes up 3 every time the x value goes up 1. What am I describing? That's the what of the line? I'm talking about the slope. Okay? I could say the exact same thing in this problem. The y value goes down 3 every time the x value goes up 1. Just check it. If the x value goes up 1, okay, that's to the right, the y value goes down 3. If the x value goes to the right 1, the y value goes down 3. Okay, so we're just describing the slope a little bit different. And then there's this statement. It says f of 0 equals 3. What is that? This is another way to write something. We usually write it a little different. Anybody remember what this is? It's function notation, but what does this mean? Like this represents something, and so does the 3. Shannon?
Isn't it like the same thing as a y?
So it's like writing a coordinate, right? There's an x and a y in here. Which one is the x? So which one is the x? 0. That's the x. Right? And what about the 3? That's the y. So what this is telling me is it's telling me the y-intercept. Okay? And we've done that before. 0, 3. Okay? That's what your paper says. The y-intercept is 3. I'm going to write it like this on the test. Right? So graph your y-intercept. Up 3. Now, let's read back what it says about the slope. Okay? It says the y goes up by 3 every time the x goes up by 1. Is the y, is that my rise or is that my run? That's my rise. Okay, my rise is going up 3, so up is positive, when x goes up 1 unit. Okay? What's my run? Is that the x or the y? That's the x. So the rise goes up, it increases 3 units every time the run increases 1 unit. Right? That's exactly what that says. So now from this point, how would I get another point on the line? What direction do I have to go? Vanessa?
You have to go over 1 unit.
So let's do the rise first, just because it's on top.
You go up 3
Up 3,
and over 1 to the right.
1 to the right. That's it. And now just draw your line. Okay, so pretty similar to the last one, just a little bit different in how they word it. Okay, any questions on that one? What if it said the dependent variable decreases by 3 for every 1 unit the x goes up? What would change here if it said it decreases by 3? Right, this would change. The plus sign in front of the 3 would become a minus. All right? Okay, so any questions on that one? All right, so let's look, I think, last one. All right, so let me read through it. There's really only one thing here you have to focus on. The rest is just describing the problem. But it says what we've got is a submarine that's exploring the ocean. And this is a formula for how deep the submarine is. Okay, that's what that is. You don't have to worry how they got this formula. That's all. That's the formula for how deep the submarine is. Any questions on that? Now, the submarine is starting to ascend. What does that mean? If it's on the ocean floor and it's starting to ascend, it's starting to go up. Okay? So what they've done for us, they've drawn a graph of the submarine going up to the surface. Okay, any questions on that? So how deep is the submarine when it starts? See if you can look at that graph and figure it out. It's down 13,000 feet below sea level. Okay? How do you know that? What tells you that it's 13,000 feet down? What on the graph?
Where the point is on the elevation.
Where the point is, what axis is this?
No. Y.
So what is that point?
Oh, the y.
The y-intercept. Exactly. So they ask us to explain what the y-intercept is, and you just explained it. Okay? I'll come back to the slope in a second. So the y-intercept shows us how deep the submarine is before it starts going to the surface. Okay? That's what the y-intercept is. How deep the submarine is before it starts going up. Now we have a y-intercept. What's the other intercept we have? Besides just the y.
What was the question again?
What's the other intercept besides the y-intercept? Yeah, there's an x-intercept here too. Okay? Remember, think of this as your y-axis. Think of this as your x-axis. The x-intercept The x-intercept is right here. What does that mean? Is that showing how deep the submarine is? How deep is the submarine at this point? How many feet? 0 feet, right? It says, if you look at your graph, in feet, at this point, the submarine is at 0 feet deep, which means what? It's at the surface. What about the 20?
But how long it took to the surface?
Exactly. The 20 is how many minutes it took for the submarine to get to the surface. So that's the x-intercept. Okay? It's showing how many minutes it took for the submarine to be 0 feet deep. Okay, so that's what you write for your x-intercept. So x-intercept is how long it took the sub to reach the surface. Hey, any questions on that? Now, the last thing I'm going to do is I'm going to find the slope. And I'm going to get an answer, and I want to know what the slope means in terms of the submarine in this problem. Okay. Do they give me 2 points? Yeah. So I could find the slope. Let's see. What could we call 0? x1 or x2? Okay, we could call it x2, which means 20 would be what?
X1.
That's x1. How about negative 13,000?
Y2.
2. And what about 0? y1. Hey, let's plug those into our slope formula and see if we can get the slope of this line. All right, so y2 minus y1. What's y2? Negative 13,000. So negative 13,000. What's y1? Okay. Yep, 0. Over. What's x2? 0. What's x1? 20. Well, if I take negative 13,000 and I don't subtract anything, what do I get? Just get negative 13,000. How about 0 minus 20? Negative 20. What's a negative divided by a negative? Positive. And now let's divide 13,000 by 20 and see what we get. 650. That's the slope. Now, does anybody know what that slope means in this problem? The 650 has a unit to it. Feet. So the sub is doing something with 650 feet every so often. What's the sub doing with the 650 feet?
It's going up 650 every day.
Exactly. This sub is going up towards the surface 650 feet every minute.
That's really fast.
Yeah, that'd be pretty fast. So that's what the slope means. Okay? So just put the sub is going up. Or you could put ascending. The sub is going up at 650 feet per minute. Now, how do we know that we're right with the slope? How do we know that that 650 is right?
Because you're a genius.
Besides that, Bailey?
Looking towards how T is.
Think back a little bit. What did they give me to start out in this problem? You should have known should have known the slope before we even found it. How come? You guys all have this printed on your paper, right, this problem?
Yeah.
Look at the top, look at what's printed in the problem. What is it? It's a formula, right? You guys have the form, what's it say in the form, what's it?
Why do we do this stuff?
They already gave you the slope. Let's see if anybody noticed. They gave you the slope right here. All right, so couple reminders. Homework, worksheet. Okay, this is online. Okay, so take out your Chromebooks. Okay, and if you already have it, you're good. If you can print it at home, that's fine too. If you can't, you have 5 minutes right now to print it. And Mr. Roy and I will go get it. Okay, other reminder, I will be after school today. When's the test? Tomorrow. Okay, so if you can't print the homework, print it now. Now is your chance to print it.
Mr. Hager.